Okay, so we're going to talk about two-step equations. And this is on page 45 of your notes. So make sure that you fill in the table on page 45. We will do examples and some more, and show another couple procedures and options of ways to do two-step equations to help you visualize the operations and things that are happening. So this is just giving you a comparison, basically a way to break down your equation. So you are given 9y minus 5 equals 8. So you can read the little story that it has about your best friend being closest and staying till last. So it's the thing that's closest to you. And then those that are further away, which would be your constant. Okay, so your coefficient and your constant. So I like to think about it as getting rid of my constant when it's written like this, or getting rid of the thing that's furthest away from the variable first. So let's go over to the example and we'll start to fill in our table. So now I want to ask, because it's two steps, so I have my first step and my last step or second step. Okay, these are two steps. You can have multi-step, 5 steps, 10 steps, etc. The most that we would have would probably be 3 right now. Okay, so it's our first step. So we notice here, our first step, we multiplied. If I do it mathematically and show my work, actually showing what's happening, I multiply both sides by -2. Okay, so then that would leave me with x plus 8 equals 12. Okay, so then I would subtract 8 from both sides, which would give me x equals 4. I got x alone. Okay, so I like to see it mathematically, but we also want you to understand it in words. So now let's do the second one. The first thing I would do is what is not closest or attached to me. Okay, I'm the x, so I gotta get rid of anything that's furthest away from it. So I would subtract 14, right? If I do it from one side, I've got to do it from the other. So my first step, or the inverse of addition, is subtraction. So I need to subtract 14 on both sides. Both sides. Okay? So then that would give me, if I wanted to see it mathematically, -3x equals 30. So what my next step would be to divide both sides by -3. Okay, and then if I worked this out, I'd get x equals -10. Okay, so now let's look here. This one gets a little tricky. I need to look and see what's going on. Now, we've been talking about this for months. Subtracting a negative is the same as adding a positive. So if I rewrote this, it'd be 4x plus 3 equals 15. I'm not going to work this one out, I just want to show the words. So my first step would be to subtract 3 from both sides, because again, here's my variable. Multiplication and division are harder to break than addition and subtraction, so I want to do the easy one. So I subtract 3 on both sides. We always do it on both sides because it's an equation and both sides are equal. So then I'm left with 4x equals 12. So then I need, my second step would be to divide by 4 on both sides. Okay, so now here's another tricky looking one. So I want to make sure that I get rid of any kind of fractional part. If I'm dividing by something on the bottom, I need to do it first. That's opposite of what we've been doing up here. Up here we've been doing multiplication or division last. But this is the whole thing divided by 3. The whole quantity of x plus 5 divided by 3. So I've got to get x plus 5 alone. So now I multiply by 3, multiply by 3. Okay, so again, multiply by 3 on both sides. Okay, So then I need to subtract 5 from both sides. Now, if you're confused on why I'm multiplying, dividing, adding, or subtracting instead of doing what it's actually there, remember your inverse operations. Operations are the following: addition, subtraction, subtraction, addition. Okay? Then multiplication is division, and division is multiplication. Okay, we will continue to go through this in class. Make sure these notes are down on page 45 in your interactive notebook.